Right now, everyone is learning AI. People are experimenting with tools like ChatGPT, Gemini, and Claude. And it feels like simply knowing how to prompt an AI is enough. But there's much more bigger shift happening beneath the surface. What happens when AI stops just answering questions and starts completing tasks on its own? When it can plan steps, use tools, make decisions, and execute actions without constant human instructions, that's where Agentic AI comes in. Agentic AI is not just about generating text, it represents a shift from AI that talks to AI that thinks, plans, takes action, and works toward goals independently. And the professionals building these intelligent systems are called Agentic AI developers. Now, this isn't just another term, it's the evolution of AI system from passive assistant to active problem solvers. Naturally, this raises a lot of questions. How do you actually become an Agentic AI developer? Do you need to come from a strong tech background? Is this only for experienced programmers? What skills are truly required? What does the role look like day to day? And of course, what kind of salary does it offer? If even one of these questions has crossed your mind, you are exactly where you need to be. In today's video, here's what exactly we'll cover. First, we'll clearly understand what Agentic AI actually means and how it's different from normal AI. Then, we'll talk about what an Agentic AI developer actually does in real life, not just theory but practical responsibilities. After that, I'll walk you through a complete step-by-step roadmap from beginner level to all the way to production level system. We'll also discuss whether you need to be from tech background and how freshers can get into this field. Then, we'll talk about certifications. Are they required or not? And finally, we'll break down salary expectations in India and in the US. And by the end of this video, you will have complete clarity, no confusion. So without any further ado, let's get started. Now, before getting started, here's a quick quiz question for you. What should you learn first to become an Agentic AI developer? Your options are prompting, Python, UI design, or video editing. Let me know your answers in the comment section below. Now, before we get started about how to become one, we first need to understand one simple thing. That is, what exactly is Agentic AI? Now, let me simplify this with a real-world example. Imagine you have two employees in your company. With the first employee, you say write a report and they write it simple. They do exactly what you ask, nothing more, nothing less. Now, with the second employee, you say increase the revenue by 20%. Now, instead of waiting for step-by-step instructions, they analyze past sales data, identify weak products, create a marketing plan, launch campaigns, monitor the results, adjust the strategy, and finally report back with outcomes and insights. Now, think about it for a second. Which one is more powerful? Obviously, the second one. That is exactly what Agentic AI represents. It does not just respond to instructions, it works toward a goal. It breaks a big objective into smaller steps, plan actions, executes them, evaluates the result, and improves along the way. In simple terms, it basically follows a cycle. The cycle is to goal, plan, action, evaluation, and improvement. And that is why it is called agentic, because it behaves like an agent. It takes initiative within a defined objective. Now, at this point, a very common doubt usually comes up, and before we move on to the roadmap, let's address that clearly. The first one is, do I need to be experienced to do this? Well, the answer is not necessarily. If you're already a developer, you will definitely move faster because you understand coding, APIs, and how systems are designed. But that does not mean that this field is closed for freshers or people from non-tech backgrounds. You can still learn it. The only real difference is your starting point. It might feel slower in the beginning, but with consistency, your growth will be steady and strong. Now, the second most common doubt is, what does the learning path actually look like? The mistake many people make is thinking that they need to build complex multi-agent system from day one. That is not how it works. You move step by step. First, you build your foundation by learning Python and understanding how software systems function. Next, you explore how large language models behave and how they generate responses. After that, you dive into prompting and tool calling, and then you learn agent frameworks. Once you are comfortable, you start building projects. And finally, you deploy them like real-world products. The journey is not overwhelming, it is very structured. Now, the third question people ask is, how long does it realistically take? Now, if you're a fresher and you stay consistent, you can build solid agent-based projects within 3 to 6 months. Now, if you're already a developer, the timeline may be much shorter. In many cases, within 4 to 8 weeks, you can start building functional agent prototypes. Now that we are clear on what agentic AI is, who builds it, and whether prior experience is mandatory or not, it is time to move into the actual roadmap. Now, I'll be breaking down the roadmap into each phase and explaining you in depth. First phase is strong Python foundation. Let me be very honest here. If your Python is weak, your agentic AI journey will feel painful. Not because the concept is impossible, but because under the hood, agent systems are just software systems. They call APIs, they handle errors, process data, store memory, and sometimes run multiple tasks in parallel. And all of that is powered by Python. So what should you actually learn in Python? Not just loops and functions, that's basic. You need to understand API calls because that's how your agent communicates with services like OpenAI or any external tool. You can think of API like phone calls. Your code calls another service, asks for information, and gets a response. Now, this is most AI systems send and receive data in, which is in JSON format. Now, JSON is a simply structured text like labeled boxes where each box has a name and a value. If you cannot read and manipulate JSON properly, building agents becomes difficult. Next comes error handling. Now, API fails, the internet fails. Data can be messy. Your agent should not crash just because something unexpected happened, right? It should handle the situation gracefully. Then you have async programming. Now, async programming is another important concept here. You can imagine this as one agent which is researching, another one is writing, and the another one is checking grammar. They should not wait in line. They should work simultaneously. And that's where asynchronous programming becomes powerful. Now, if you're a fresher, you can start small. You can build a script that fetches weather data from an API, build another one that reads a CSV file and summarizes it, create one that sends automated emails. Now, these small projects build confidence and practical understanding. If you're already an experienced developer, your focus should shift to clean architecture, modular system, designing, logging, scalability, and concurrency patterns. Production level agents require structure, not just functionality. Now, there are also some important libraries and the use cases. Libraries like Matplotlib, Seaborn, Pandas, NumPy, NLTK Python, Scikit-learn, and TensorFlow. So you can also master these frameworks as well. Let's move on to a second phase, which is understanding large language models properly. Now, we have already talked about Python, but remember, Python is just a vehicle. The real intelligence inside an agent does not come from Python itself. It comes from large language models or LLMs. So before we try to build smart agents, we need to understand how this AI brain actually behaves. And don't worry, we are not diving into research level math here. We just need to understand how it works at a practical level. Because once you understand its behavior, you can design better systems. Now, let me break this into three simple concepts here. The first one here is tokens. Now, you can think of like this: when we read a sentence like agentic AI is powerful, we see words here, right? But a large language model does not process languages like we do. It will break text into smaller pieces known as tokens. You can think of tokens like the Lego blocks here. Every sentence is built from these small pieces. This matters because more tokens mean more memory usage, higher cost, and slower processing. If your agent handles long conversations or read long documents, token management directly affects performance and cost. So tokens are not just theory, they influence real system design. So here, as you can see, when you give a text like AI is amazing, it will be breaking into tokens like AI plus is amazing. Next, let's talk about context window. Now, every large language model has a limit on how much information it can remember at once, and this is called the context window. You can think of it like short-term memory. If someone talks continuously for like 2 hours, you probably forget what they said at the beginning, right? AI works in the similar way. When the input becomes too long, older information gets pushed out. For agent developers, this becomes important because agents often handle long conversations, they analyze large documents, and they use past decisions. Since the context window is limited, we design memory system. summarization layers, and retrieval system instead of sending a full 100-page document every time. We summarize key parts or use vector databases to fetch only relevant information. So the context window is not a problem, it's a design challenge. Next, let's talk about embeddings. Now, because this is where things become powerful, machines do not truly understand language, they understand numbers. Embeddings convert text into numerical representation, but they're not just random numbers. They map text into coordinates in a multi-dimensional space. You can imagine a huge map where every sentence becomes a point. Sentences with similar meaning are placed close to each other. For example, I love artificial intelligence and I enjoy learning about AI. They use different words, but their meanings are similar. So they sit near each other in this space, and this is what allows system to search by meaning instead of just keywords. This is how RAG system, which is memory-based agents and intelligence search mechanism work. Embeddings are what makes agents feel smart. Now connect everything. Understand how a large language model processes tokens, how memory works through context windows, and how meaning captured through embeddings. But here's the key question. Even if you understand how the brain works, how do you guide that brain to behave properly? How do you control its thinking and make it act toward your goal? This is where prompt engineering and tool calling comes in. Not just because a model is powerful does not mean it will automatically behave the way you want. Many beginners assume that if the AI is smart, it will figure things out on its own. Well, it won't. You have to guide it intentionally, and that guidance begins with prompt engineering. So moving on to our third phase, which is what is prompt engineering, let's talk about something that sounds simple but is actually very powerful. The prompt engineering is not just about typing instructions into ChatGPT, it is about designing behavior. You can think about it in this way. Imagine you hire a new employee. If you simply say do this, they might misunderstand you. They won't know which repeat. If you say do this, they might misunderstand you. They won't just know what tone to use, what format to expect, and how deep to go or what constraints to follow. But now imagine when you say you're a financial analyst here, analyze this report, focus on the risk factors, present your findings in bullet pointers, and keep it under 200 words. Now, suddenly the instruction is clear, the output becomes structured, and this is where prompting comes in. Now, you are defining the role, the goal, the constraints, the format, and the context as well. You are shaping how the AI thinks before it even starts generating. Now, in simple chatbots, prompting just improves output quality, but in agentic system, prompting controls behavior. Agents break goals into tasks, decide which tools to use, interpret results, and choose the next step. If your prompt is vague, your agent might become unstable. If your prompt is structured, your agent becomes reliable. So prompting is not a decoration, it's a control logic. Now, let's move on to the powerful part, which is tool calling. Up until now, everything we discussed was happening inside the AI's brain. But this is where we connect that brain into the real world. And this is the moment where AI stops being just a chatbot and starts becoming an agent. So let's take a very basic example here. A user asks, what is the today's stock price? A normal AI model does not have live data, so it might guess. And guessing in real-world system is dangerous. Now, an agentic AI system behaves differently. It recognizes that real-time data is required, calls a stock API, fetches the live price, formats the responses, and returns accurate information. That is known as tool usage. Tool calling means that AI can decide to use an external function or API. Instead of just generating text, it generates a structured request like call function get stock price with argument ticker equals to AAPL. Calling here means that the AI can decide to use an external function or API. So instead of just generating text, it generates a structured request like call function get stock price with argument ticker which is equals to AAPL. Now your system executes that function, it returns the result to the model, and the model continues reasoning. This creates a loop: think, call, tool, get result, think again, act. This is the foundation of true agent behavior. Now, as an agentic AI developer, these are the practical skills you must master. First, knowing when to call a tool, the AI must understand whether it knows the answer or it needs external data. Second, passing arguments correctly because APIs require structured input and the wrong format might lead to failure. Third is interpreting tool responses. Now, since APIs often return messy JSON that your agent must parse properly. And this is where software engineering meets AI reasoning. Think of it like a manager in a company. If an employee needs financial data, they do not guess. They go to the accounting department. Tool calling is the AI going to the accounting. Without tool usage, your agent is limited. With tool usage, your agent becomes powerful. Now we'll move on to the next step, which is combining all of this into a structured system that can think, act, and improve intelligently. Agent frameworks. So now that you understand how to guide AI behavior using prompt, connect AI to tools using function calling, create reasoning loops. But here's a challenge. If you try to build a serious agent system using only basic scripts very quickly, things become messy. You'll have to use long prompt chains, confusing logic, memory scattered everywhere, tools call mixed with reasoning, hard to debug workflows. And that's exactly why framework exists. Why do we need agent framework? Let's answer that first. Think of it like this. If you want to build a small hut, you can probably manage it manually without much planning. But if you want to build a skyscraper, you need blueprints, structure, and proper architecture. The same idea applies to agentic AI system. Agent frameworks are those blueprints that will help you manage memory, handle multi-step reasoning, orchestrate tools, define agent roles, and control execution flow in a very structured way. Instead of just writing chaotic scripts that quickly become unmanageable, you build organized, scalable system designed to handle complexity properly. So let's understand what do these frameworks actually do. Let me break it down in simple terms. Now, when we talk about memory management, remember the concept of context window. Frameworks help you store conversation history, retrieve relevant context, inject memory back into the prompts, and manage short-term versus long-term memory. This ensures your agent does not forget important information while handling complex tasks. Now think about multi-step reasoning. Agent tasks are rarely completed in a single step. For example, if the goal is to create a competitor analysis report, the agent might need to conduct research, extract data, summarize findings, compare competitors, and format the final output. Frameworks allow you to break this process in a very structured stages, almost like a checklist that the agent follows systematically. Talking about tool orchestration here. Now, earlier we discussed tool calling, but real world agents often need multiple tools such as web search, database queries, calculator, email senders, or CRM access. Framework help manage these tools in an organized way. They guide the agent in deciding which tool to use, when to use it, and what to order, keeping the workflow clean and efficient. Finally, let's talk about the agent roles here. This is where things become truly powerful. Instead of just having one agent trying to do everything, you can design multiple agents with specific roles and responsibilities. And that naturally leads us to the next important concept here, which is multi-agent system. Now, let me just simplify this for you. Imagine a company where the CEO sets the overall goal, the manager breaks the goal into smaller tasks, employees execute those tasks, and a reviewer checks the quality before anything is finalized. Now, imagine each of those roles being handled by an AI agent. That is multi-agent architecture. In this setup, one agent might specialize in research, another in writing, another in fact-checking, and another one in tool execution. So instead of just using system trying to do everything, you create specialized agents that collaborate to complete complex objectives efficiently. Now, let's talk about the frameworks that will help you build this. Well, there are several popular agent frameworks available today, and each one has own strength. Some of the well-known ones include CrewAI, LangChain, LangGraph, and AutoGen. LangChain is very popular and highly flexible, making it a strong starting point for many developers. Talking about CrewAI, so CrewAI is particularly useful when you want to design role-based multi-agent system where different agent handle specific responsibilities. Autogen focuses more on agent-to-agent conversations and collaborative problem solving. LangGraph, on the other hand, it will give you more control to graph-based workflow, which is helpful for building structured and complex execution flows. The key thing here is to remember that you do not need to learn all of them at once. That often leads to confusion. Start with one framework, understand it deeply, and build real project using it. Depth matters more than collecting tools. So this is the turning point. If you truly want to level up, you need to move beyond learning and start building. Now, let's shift to the most important part of the journey, which is creating real world projects that demonstrate your ability to design and deploy intelligent systems. This is where our phase 5 comes. But understanding something is very different from building it by yourself. Now, when you actually build from scratch, you face real problems, APIs fail, prompts break, memory behaves unexpectedly, outputs become inconsistent, and that is exactly where real growth happens. So, what should you actually build? Let's make this practical. Now, instead of just random demos, build systems that stimulate real business problem. Let's say, for example, here you could build a customer support AI agent. Now, this agent can read customer queries, it can search for knowledge base, it can use tools to call to fetch relevant information, draft responses, and escalate complex data when needed. When building this, you learn retrieval system, memory handling, tool orchestration, and structured prompting. Another strong project is research and summarization system. Now here what it will do is your AI agent will extract the web, extract relevant information, summarize it, validate fact. This push you to implement multi-step reasoning, tool usage, data cleaning, and proper output formatting. You could also build an email outreach agent. Now this agent reads CRM data and then it will send it through an API like an email service provider and track responses. Now you are combining automation with real world integration. We're talking about resume filtering agent. This agent is another powerful idea. Users upload resume and the agent extracts skills, compares them with job description and rank candidates. This teaches you evaluation logic and structured comparison system. These are not just toy examples, these are the kinds of systems that demonstrate that you can design intelligent workflows and not just generate text. And that is what truly separates learners from builders. Now, many people stop the moment their system works, but real engineering actually begins after that point. Once something runs successfully, the next step is to edge cases and stress the system properly. You should start asking tougher questions like what happens if the API fails? Does the agent retry automatically or does it crash? What happens if the user input is strange or completely nonsensical? Can your system handle it gracefully? What if a tool returns an unexpected JSON format? What if the LLM produces hallucinated or inconsistent output? Once your agent are working reliably and you have handled failures properly, there is one more layer that makes system truly powerful. And this is where feedback loops and adaptation comes in. Let's move into that. So moving on to our sixth phase, feedback loops and adaptation. So what is feedback loops here? Let's simplify it. A feedback loop means a system measures its result and then it adjusts its behavior based on that result. That's it. For example, you can imagine you run an online business, you send a marketing email and then it checks and it opens the rates. If the open rate is low, you can change the subject line next time. That process, observe, adjust, improve, it's a feedback loop. Now imagine your AI agent doing that automatically. Suppose the AI agent writes marketing emails. Here's what it happens. First of all, the agent will generate the email. The email will get sent. The system tracks open rate and click rate. The agent analyzes performance. The agent will modify its subject line strategy next time. The system is evolving. It's not just static anymore. It is adaptive. Why is this so powerful? Because without feedback loop, your system behaves the same way forever. It does only what you originally designed. With feedback loops, your system becomes dynamic. It improves based on outcomes, and this is the difference between static AI and adaptive AI. Now, let's simplify the technical side. You need to focus on four main components here. First is metrics. Now, metrics, which means what are you measuring? Open rate, accuracy, completion rate. Next is logging. It means storing outcomes in a database or analytics system. Decision logic. If a metric falls below a threshold, modify strategy. Update mechanisms. Change the prompt, adjust parameters, switch tools, or modify workflow. This does not always require complex machine learning. Sometimes simple conditional logic is enough. The real shift is in mindset. You are building systems that evolve. Now, let's move on to our seventh phase, which is deployment and production system. Imagine this for a moment. Your agent is no longer running on your laptop. It's not a demo product anymore. It is not a weekend experiment. Instead, imagine 5,000 users which are trying your agent every single day. Some are uploading files, some are sending requests, some are triggering automated workflows. Many of them are using it at the same time. Now, at this stage, everything changes because building an agent is one thing, running it reliably in the real world is something completely different. And this is where real world engineering begins. Now, when you build locally, everything feels smooth and controlled. But in production, APIs might fail, users send unexpected inputs, traffic suddenly spikes, servers crash, cost increases, and security becomes critical. Your job is no longer just to make it work, your job is to make it stable, scalable, and secure. So the first step here is to containerize with Docker. Let's simplify Docker here. You can think of Docker as putting your entire project inside a sealed box. That box includes your code, dependencies, libraries, and environment settings. When you move that box from your laptop to the server or to the cloud, it behaves exactly the same. Without Docker, systems often break because environments differ. With Docker, everything stays consistent, and that is why it is essential. Second one is deploying on the cloud. Now, once a project is packaged, it needs a home. That home is the cloud platform like AWS, Azure, and Google Cloud, which will allow your system to run 24/7, scale automatically, handle thousands of users, and store logs and data. Next is adding monitoring. Now imagine your agent stops responding at 2 a.m. How would you know? This is where monitoring is critical. Monitoring tracks response time errors, API failures, and usage spikes. It alerts you when something breaks. Now this is what production engineers focus on every day, visibility into system health. Next is add logging. Logging means recording what your system is doing internally. When an agent makes a decision, you should know which tool is called what. You should know which tool is called, what input is received, and what output is generated. Logs are your debugging history. Without logs, you are essentially blind when something goes wrong. Next step is securing API keys. Agent systems depend heavily on APIs, OpenAI keys, database credentials, third-party integration. If those keys are exposed, your system can be misused or attacked. In production, keys must never be hard-coded. These should be stored securely and managed through environment variables or secret managers. At this stage, security becomes serious. Next step is managing rate limits. Most APIs have request limits. If 5,000 users trigger your agent at once, you might exceed those limits. To handle this, you need request queues, retry mechanism, and throttling strategies. Without these safeguards, your system can crash under load. Now, this particular phase is really important. Next, let's talk about the certification, whether a certification is really important or not. Because a lot of people believe that certification alone guarantees a job. That is simply just not true. A certificate by itself does not create opportunities, skills do, execution does, project does. Now let's be practical. Is certification mandatory? No. Is it helpful? Yes. Especially if you need structure, are transitioning from another field, or want guided project experience or stronger resume positioning, then certification is really important for you. Now, if you're looking to transform your career and you can get ahead in the AI and automation space, then Simplilearn has partnered with IHFC TIH of IIT Delhi to offer the professional certificate program in generative AI, machine learning, and intelligent automation. This program is perfect for anyone who are eager to develop cutting-edge skills in AI and automation and land a top job in industries that are rapidly adopting those technologies. So here's what you will get. A program certificate from IHFC TIH of IIT Delhi powered by Simplilearn. 2-day campus immersion at IIT Delhi and exclusive IHFC executive club status. Microsoft course completion badges and trophies to showcase your skills. 20 plus AI tools, 12 plus real world projects, and work on building strong portfolio. Master classes from industry experts, including intelligent automation application and Agentic AI. So this 11-month program is designed to equip you with the most relevant in-demand skills that every industry needs today. Plus, you'll have hands-on learning and get the chance to work with top AI tools like Python, TensorFlow, OpenAI, LangChain, and many more. So if you're ready, you can hurry up and enroll now. The course link is mentioned in the description box and in the pinned comments. Now let's talk about something everyone is curious about, which is the salary. Now, in the United States, AI engineer and agentic AI roles are already commanding strong compensation. Most mid-level professionals are earning anywhere between $130,000 to $200,000 per year, and senior roles can go well beyond that depending on expertise and company scale. Specialized engineers working on advanced agent system or large-scale AI infrastructure often sit in the higher or end of this range. Now, looking at India, then the freshers can expect around 6 to 12 lakh per annum. For mid-level roles, the salaries goes from 15 to 30 lakh per annum. For senior roles, the salary goes from 40 to 60 plus lakh per annum. If you specialize in agentic, multi-agent system and production level deployment, you position yourself toward the higher end of these ranges. The deeper your system design and real-world engineering skills are, the stronger your earning potential will become. Now, let's cruise this the right way. Agentic AI is not just another framework you add to your resume. It's a mindset shift. You are no longer writing every piece of logic manually. Instead, you're designing intelligent systems that can think, plan, act, adapt, and improve over time. This is a completely different level of engineering. The journey does not require genius level intelligence, it requires clarity, consistency, and structured effort. So start small, build consistently, focus on real world projects. Instead of just endless tutorials, learn the fundamentals deeply. Test your systems properly, deploy them, improve them. Now, if you follow this path, you will absolutely become an agentic AI developer. And if this breakdown helped you understand the full roadmap, make sure to like the video, share it with someone who wants to break into AI, and subscribe to our YouTube channel for more structured practical guidance on building real AI systems. Thank you and keep learning with Simplilearn.